Good morning all. Let us solve a problem using Ampere's law. Find the magnetic field a distance S from a long straight wire carrying a steady current I. We have to evaluate what is the magnetic field at a distance S from a long straight wire carrying a steady current I. We have solved the same problem using Biot-Savart law, and this time we are solving the same problem using Ampere's law. We know that by right hand rule, if the current flows through a long straight wire, then the direction of the magnetic field is circumferential. That is, the magnetic field will circles around the wire if the current flows through a long straight wire. The direction of the B is circumferential. Now, to find out the magnetic field at a distance S from a long straight wire, draw an Amperean loop of radius S centered on the wire. Now, since the magnetic field is circumferential and it circles around the wire, if we observe the magnetic field, you can see that around the Amperean loop that we have drawn, the magnitude of B is constant. This is because of symmetry. Now, by symmetry, the magnitude of B is constant around the Amperean loop of radius S. Thus, to find the magnetic field at a distance S from the long straight wire, you first draw an Amperean loop of radius S, which is centered on the wire. Then Ampere's law says that closed integral B dot dl, that is equal to mu 0 I enclosed. That is the line integral of the magnetic field around the closed path, that is equal to mu 0 times the enclosed current. Since our Amperean loop contains the current I only, we can say that the enclosed current is nothing but I. Since the magnitude of B is constant around the Amperean loop, you can take it outside the integral. So B into closed integral dl, that is equal to mu 0 I. What is the value of closed integral dl? That is nothing but 2 pi s, the circumference of the Amperean loop. Hence, B into 2 pi s equal to mu 0 I, or B is equal to mu 0 I by 2 pi s.